Welcome students. In the previous class we discussed about the potential energy and how force can be represented in terms of potential energy, then conservative force, etc. All we discussed. Now we can discuss or study about energy diagrams. In this we will be studying about the potential energy curve, how it can be used to explain motion of different systems. That only will be discussing, especially will be moving into bound system, unbound systems. First we will start with the energy diagram. What do you mean by energy diagram? Energy diagram means it is a graph that is representing a pictorial representation of energy and potential energy as a function of position. We will be representing position along x-axis, energy that is taken along y-axis. In the graph we will be representing total energy and potential energy. If we are representing only potential energy, the graph will be called as potential energy curve. And important thing is that when we discussing about any potential energy graph or curve, there we have to calculate, we can calculate kinetic energy. That is all we discussing in the case of conservative force only. So K is equal to total energy, mechanical energy minus potential energy. And we will be discussing constrained motions. Motion is constrained. Which area the motion will be constrained? That is based on the value of potential energy. This potential energy, we know that expression is half mv square. Its value will be never negative. So K is greater than or equal to 0, means positive. It should be 0 or a positive value, kinetic energy. So that values for potential energy and total energy we will be taking, and on the basis certain motions will be possible with positive kinetic energy. That only will be discussing. And for that case, this U, potential energy value, that should be always less than or equal to total energy. So all this will be looking with the help of an example, that is for harmonic oscillator. This is the case of harmonic oscillator. Harmonic oscillator means simple harmonic motion where potential energy is half kx square and the total energy, that is a constant. Conservative force is there. That is the reason why total energy will be a constant. So this graph is representing total energy. This line is representing total energy. Potential energy is represented by the parabola. Half kx square is there. So we will be getting one parabola, and at this point, that should be vertex will be at the origin. And if you look out, we can see potential this kinetic total energy value, and we will be using this shaded area. Shaded area, that is the only region in which the motion is possible. So beyond this region, here you can see potential energy value that is greater than U. Here also potential energy value that is greater than U. So this situation, the motion is not possible. So motion is restricted in the region where kinetic energy is equal to E minus U, and value of U should be always less than E. That is the condition. Kinetic energy value, anyway, potential energy value should be less than E. If it is greater than E, what will happen? Kinetic energy will be negative, which is an impossible calculation. And here we can see 2 points. 2 points means at this point potential energy that is equal to total energy, means kinetic energy is equal to 0. So the system will not go into this area, so it will come back to its initial state. This situation, it will never go back to which area? This area. This is the turning point. So if we look out the motion of a simple pendulum or any harmonic oscillator, it will move from here to here. When it reaches at the position x2, it will come back to original position and it will move. And this is the mean position. At this position, energy will be, kinetic energy will be maximum. The things only we explained. Potential energy curve. The difference between potential energy at the bottom, this is the bottom point, and potential energy at top, this is the top point. This will be called as potential well. That is called as potential well when any particle is oscillating in between 2 points about a mean position. That will be called that. It is equivalent to motion in a potential well. And the height of the potential well, that should be calculating from where to where, bottom of the potential energy curve to the total top of the potential energy curve, equivalent to energy, total energy. Now, if the energy given to the particle that is less than the height of potential well, we are having certain potential well, and height of the maximum kinetic energy we can give so that it should oscillate about its mean position, and we are providing energy greater than that. We are providing certain external energy greater than that. It will come out of the potential well, and further it will not execute oscillatory motion. So the oscillatory motion that should be possible if we provide the energy that is less than or equal to the potential well. If you give large amount of energy, means it will never execute oscillatory motion. If you stretch the string beyond a certain limit by giving large amount of energy, it will be deformed. That only we are saying. It will not execute oscillation. So below the potential height of the potential well, it will execute oscillatory motion about the stable point of equilibrium. That mean position at the center or at the origin, that is called as stable equilibrium position. It's an example of bounded motion. So this is example of bounded motion, bound system. Now we'll be looking at another thing, that is an unbound system. Here we'll be looking out a proton, a particle, energy diagram for a particle constrained to move by repulsive inverse square law force. We'll be looking out force that is repulsive. Then it should follow inverse square law force. All we will discuss. Inverse square law force, that means force directly proportional to or inversely proportional to radial distance r. This type of force that is called as inverse square law force, and it should be repulsive. Means a proton is approaching towards a nucleus. Charge of the nucleus we know that is positive, and a proton is approaching towards a nucleus means positive charge is approaching towards a positive charge center. So there will be repulsive force. That only will be discussing. When the proton is approaching the nucleus, we can see that when it is getting very close to the nucleus, what will happen? There will be repulsive force, because this positively charged nucleus is there, proton is having positively charged. When they close to each other, there will be repulsive force. If the proton is very large distance, then there will be less amount of repulsive force. But when it is getting very close to the nucleus, what will happen? Potential energy value that is getting very large. Potential energy is getting very large, and kinetic energy value that should be getting very less. So when it reaches at any particular point, kinetic energy becomes zero. Kinetic energy is become zero. This point is, at this point, potential energy value that should be maximum, and further it will not get close to the nucleus. If it get close to the nucleus, means kinetic energy should be negative. That condition is not possible. So it will never go to the never get close to the nucleus beyond this position r minimum. This is called as minimum closest approach. The distance of minimum closest approach. This distance is called as distance from nucleus to this point. That is called as distance of closest approach. So after reaching this point, it will go back to infinity, means it will follow the same path. Anyway, the kinetic energy will be having, potential energy will be having, or the velocity will be having same values, and it will the velocity of the particle will be reverse, and if you look out the path, that should be exactly reverse way in the reverse motion. Means when it reaches, the proton will reach near the nucleus. After reaching the nucleus, its velocity will be getting reversed, and the particle will move in the reverse direction, means opposite direction towards the infinity. The particle will, the proton will get close to the nucleus up to closest minimum distance of closest approach, and further that it will go to the infinity, and velocity will be just reversed. So that only explained, we can go through it. A force will be inverse reciprocal force, that is written here, and potential energy minus anyway force, by integrating force will get potential energy, that only written here. Then proton is approaching towards the nucleus, that is the situation, that only will be explaining there. When it reaches at a distance, minimum kinetic energy becomes 0. Further it cannot go close to the nucleus. The distance is called as distance of closest approach. The proton reverses the motion and goes to the infinity. Proton will reverse the motion at kinetic energy is equal to 0. That position, it will reverse the direction and it will go to infinity. And this is not a bound system. Here it is not forming a bound system. It is an example of unbound system. Here we will be discussing about forces are conservative force only, but the system is not forming a bound one. And next we will be looking out Morse potential energy curve. Morse potential curve. Morse is name of the scientist only. With some potential, bounded and unbounded motion depend upon the energy of the particle. If you discuss certain potential, the bounded and unbounded motion depend upon the energy of the particle. Whatever will be the energy, on the basis of that, we can say that the system will form bound system or unbound system, and thereby we can discuss molecule formation of the molecules. That only we'll be discussing in this session. This is always associated with the formation of gas molecules. So first we will discuss oscillation of atoms of a molecule. We'll be discussing about oscillations of atoms of a molecule. If two atoms are get close to each other, there will be attractive force or repulse. There will be force between the molecules. Attractive, repulsive, all this we will be discussing. So these molecules, there may be some forces. That forces, that is called as van der Waals force. That is the weak force, weak van der Waals force. So molecules are formed by weak van der Waals force. That force is proportional to 1 by r raised to 7. That much very small. So potential energy curve of the molecule satisfying van der Waals force is given below. We can see the potential energy curve. This is the potential energy curve for the associated with the van der Waals force. Means force between two molecules, that is given here. Two atoms, when they close to each other, this will be the potential energy between them. And if you look out, we can see if the molecules are very far, then there will be less amount of force. The force will be almost equal to 0. Then if you bring the atoms very close to each other, we can see certain point here, potential energy become negative and a very large value. This here, the attractive force will be more. At this point, the attractive force value will be very large. Then if you decrease the distance, what will happen is that potential energy value is actually increasing here. Negative value is decreasing, means potential energy is increasing and it reaches to 0. Further, it becomes positive. So value of potential energy is getting more.